Here is the last of the application problems. So half-lives are basically it's just the time that it takes for one half of the substance to decay. So if I have, for example, 30 grams of some substance, then in order for this to be now 15 grams, the time that it takes for it to go to 15 grams is what we call the half-life. So this T is what we're going to call the half-life. And different chemicals, different substances have different half-lives, the rate at which things are decaying. Okay, so the formula is basically the same. The only thing that's different is that now you have a negative. So it's a negative RT, but everything is just the same. The time usually is what what's gonna be the half-life, so the time that it takes. Okay, so the half-life of caffeine in the human body for a healthy adult is approximately 5 hours. So what is the exponential decay rate? So first, let's go ahead and write down our formula. P of t is equal to P e to the negative RT. Okay, so here, just like we have the other problem, I don't know how much is initial. Initial, I don't know what it is. I know that the time, which is the half-life, is 5 hours. I don't know what my rate is. That's what we're solving for. We want to find the rate. That's basically all I have. I also don't know what P of t is. So the population or the amount at 5 hours, I also don't know what that is. But I know that because this 5 hours is the half-life of caffeine, it doesn't really matter what P is. I know that at 5 hours, I will only have 1/2 of P. Okay, so then I'm going to have e to the negative R. R, I don't know what that is, and T is just going to be 5. Okay? All right, now let's go ahead and solve a little bit. So the P's are going to go away. So I'm going to have 1/2 equals e to the negative R times 5. Okay, now I need to bring this negative R to the 5 power down. So I'm going to take a natural log to both sides, ln to both sides. Okay, and what I'm going to be left with is going to be the 1/2 here, and then e to the negative, let me write 5R. So this negative 5R is going to come to the front. Ln of e is just going to be a 1, so I'm going to be left with negative 5R is equal to ln of 1/2. Now let me divide by the negative 5. So this R is going to be approximately, so let's round to 4 decimal places. So I'm going to have ln of 1/2 divided by negative 5. That's going to give me 0.1386. That is going to be my rate. Okay? All right, now what we're looking for the next part is how long will it take for 95% of the caffeine consumed to leave the body? Okay, so I'm still going to use my same formula. P of t is equal to P e to the negative RT. Now I know what my rate is. My rate is going to be 0.1386. Now I do know what my half-life is, but I'm not really looking for that. That's not really going to be relevant here because we're looking for how long will it take for 95% of the caffeine to be consumed. So we're not looking for half of it. Now we're looking for 95% of it. So now, what am I going to do here though? Because this is going to be P e to the negative R, which is just going to be 0.1386. And the time is what we're looking for. Now, how can I use this 95% with this P of t? Now, many of you guys may think, okay, I should just do 0.95 times P. Well, that is not quite the answer because 95% of it has already been consumed. I have consumed 95% of this caffeine. So in order for me to do this, this 0.95 times P means that I have 95% of the initial. And that's not what I have. How much do I have left? I only have 5% of it left. So this shouldn't be 0.95, it should be 0.05 of the initial. Okay, so there's a difference there. And now what's going to happen here, now the P's are going to go away. I'm left with 0.05 is equal to e to the negative 0.1386. times t. Now let's bring that thing from the sky to the bottom. Let's take natural log to both sides. So I'm going to be left with 0.05, then e to the negative 0.1386 to the t. This is going to go to the front, and this ln of e is just going to turn into a 1. So I'm left with negative 0.1386 times t is equal to ln of 0.05. Now let's just divide by this negative 0.1386, divide by this negative 0.1386, and that should give us the time. So let's see what the time should be. So the time is going to be ln of 0.05 divided by minus 0.1386. And what I get approximately is 21.6. Okay, now was this in hours? I forgot what that was. It was in hours, yeah. So it's going to take 21 hours in order for there to only be 5% of caffeine inside of me, or 95% of it has been consumed. Okay, so we do need to read the question carefully to figure out what exactly we want. Okay, and that's it.